Welcome to Hacking ML for Marketing. So the company I am a co-founder at, and I'm the CTO at, called thredUP, started about 9 years ago, and we've grown to being the largest online consignment store for women's and children's clothes. Our mission is to inspire a new generation of consumers to think secondhand first. And how are we doing that? Well, we've done a number of different models over the 9 years that we've been in business. And where we landed on is that in marketplaces, often the supply side is the most constrained. And so we really tilt our strategy towards thinking about supply first. The whole idea for the business started many years ago, 9 years ago, when one of our co-founders is looking at his closet and thinking, there's a ton of value in here that I don't wear, I don't use, that I need to unlock by getting these clothes available for people to buy. And the options at the time, eBay, Craigslist, there's others, but they were very manual, very tedious. And so what we've come to is this business model where you request a bag, like you can see in the photo and on the app. You request a bag, you get it, you fill it up with clothes you want to get rid of, and you send it to us. So we're currently just in the US, as the previous slide said, 4 distribution centers across the country. That bag comes to us, and we do all the work for you. So when you're thinking about the value proposition of thredUP, we're talking about convenience with a prepaid bag, earning cash, or donating the clothes and contributing to a charity, and ultimately, regardless of which route you choose, doing good. On the buyer side of the marketplace, you get amazing prices, wide assortment, fresh everyday selection, and it's just a great, fun experience, our customers tell us. And so this two-sided marketplace, you could be a buyer, you could be a supplier, and you could be both, but we sit in the middle and we augment the marketplace to try and make it healthier and move faster and be more successful for the users and for us than if we stayed away from it and just let buyers and suppliers connect. So what does that look like in our world? Well, throughout that process of trying to augment the marketplace, we're using machine learning and data science and analytics and all sorts of different methods to really enhance what's happening. And on the far left here, you can see different types of bags that we have sent into us. You have luxury bags for high-end designer goods. You have our typical bags that you can fill with anything you want. Partner bags means bags that we're partnering with companies like Target or Reformation or other companies to distribute bags, and then you earn credit for spending on in their stores. And then wholesale, where we try and supplement the inventory so that we don't have holes in the inventory after you process things. Everything comes into our distribution center, and that's like a big part of the secret sauce I'll talk about in a second. And then there's multiple channels like our e-commerce experience, the subscription box experience, our retail stores, and then we even have an aftermarket channel where for the things we can't accept because of quality, we try and sell and make the most we can from it. But like I said, at the heart of this is a really complicated distribution center where over time, we started with very manual racks and storage of items, but over time, we've grown up a very sophisticated set of systems and algorithms to power how items are moved in an automated way through our distribution centers and then stored in dynamic storage such that there's minimal user or minimal operator movement through those distribution centers. And so as you can see here, items as they flow in are being brought into inventory, but before this step, you've got a whole series of steps around inspection, photography, itemization that go into this, and at each step along that path, we're making decisions and using data to try and decide what happens next. And so when you think about the marketplace, the big question of a company like us is how do we keep growing? How do we grow the marketplace? And when you've got an installation that's like you saw before, there's a huge capital investment at each stage where you grow a new marketplace and invest in that kind of automation. And so that really happens in steps, but at each step, it's really important that we're thinking about the throughput of goods from the bags coming in, the items into the marketplace, the best items, and then all the different experiences to be able to actually sell and move those items. When you think about the traffic on the left here, all thredUP visitors coming to the site, and shopping, but then also requesting bags. And then the bags that they return and the items we accept from those bags, how we price them, and then how we discount or promote them to ultimately sell pretty much all the items we get, there's a large number of activities and decisions that are made along this path and systems that help to drive a better user experience to move those items through. At each step, if you think about right at the top, we've got marketing, which we're going to dive into in a deep way in just a minute. But then you've also got supplier scoring. So when people go to request a bag, we've graded you based on your past experience with us, based on what you maybe have shopped, what you've supplied to us before. We've done a lot of work to try and say, should you get a bag, given that we have tons and tons of supply in the system? What bags get returned to us? So like how we market to you, once you have a bag at home, you've requested it comes to you in an envelope, whether we prompt you to bring you back, whether we offer you a bonus or not to send that back. There's all sorts of ways that we can influence getting you to return that to us, and who we want to send us that bag so that we get the best inventory into the system is really important. Items accepted is all about the decision once we have the bag and we inspect it and it passes the quality threshold. There's still a certain set of items that we actually want to put into inventory, and so there's a decision about which items that we do there, and then there's a whole modeling system there around how likely that item is to sell and in what time, and then we use that as a way of deciding whether to accept and put that in inventory or not. The pricing system itself, which I think you'll hear a little bit about, the pricing system has some layers of sophistication to it to help us think about, and it started as just a simple lookup table set with some rules base and has over time grown and grown and grown and has many different aspects to it that allow us to have a very sophisticated pricing system across 30,000 and more brands and all the different categories that you'd imagine. And then as users are experiencing the site and our apps, you've got personalization, notifications, lots of different areas to influence. And for us, even though we're 9 years in, there's still a ton to do here. And it's a great opportunity for any of you who are really excited about what I'm talking about to actually work with us, because lots of problems and interesting challenges to solve along the way. But where we're going to spend the next 30 minutes or so is diving into marketing and how specifically we think about highly efficient marketing and driving a better return on the dollars that we're spending, such that as we spend those dollars, we're maximizing the throughput through the system, and that we can minimize that capital investment to grow the overall pie. And so I'll invite Tetiana to come on up and tell you all about our efforts there.
Thank you, Chris. Thank you for turning on my microphone. And just to mention, for the best question, we will have a small prize. So we invite you to ask the questions. What does it mean to acquire people and efficiently allocate budget at thredUP? It means to answer a question. When you spend money on one of the channels, like social network, like Facebook or Pinterest, when you invest in paid search, when you invest in TV spots or SEO, you would like to know a few things. First of all, what users are coming from what channel? So this is attribution question. Second, how many users will actually make the first purchase, conversion rate? And third core question is what is the lifetime value of the users and how long it will take us to get back our investment to acquire a user. So I would like to talk how we answer all these questions using models at thredUP. With our team, we made 3 conversion rate prediction models. I will answer why do we need 3 of them. We have lifetime value prediction, and we constantly iterate to improve that approach because this is very interesting and a lot of challenges there. And I will touch TV attribution as one of the core model to correctly manage a large spending channel. First of all, we had to understand what our visitors are likely to convert, and we had to make a decision what user segments we would like to create and how we would like to spend our money to retarget these users and get them back. We created a model that runs every 3 hours and predicts if our most recent sign-ups will convert in another 14 days. This is like sensitive model that reacts a lot on user engagement with our site, on number of visited pages, on number of views, and this model is accurate and it has a great impact for the business. When we first implemented that model, our cost per acquisition decreased by 50%. If you imagine a large e-commerce site, 50% of decrease in one of core areas is a lot of money. So this model is used to create audiences, for example, Facebook audiences. And one way of thinking about this, you can put all users with high chances to make a first purchase into one bucket and spend all your budget for these users to make sure they are purchasing from you. Another way of thinking about this, these high intent users will convert anyway, and you can push a little bit this medium group to help them to convert. And this is something we are constantly working together with marketing team to create better segments and to increase our efficiency. But after that, we had another challenge with conversion rate. You could imagine that visitors are signing up and you would like immediately to say, if you created a new campaign on Facebook, for example, you would like to be able immediately to say, okay, this group of users is performing better than average. Why don't we spend a little bit more on this group of users? And you may not necessarily be interested only users who signed up within last 7 days. So we made a model that predicts conversion rate over the for the next 60 days. And why 60? It is a point in time when conversion rates stop incrementally decrease. So this model helps us to create really accurate estimation of 60-day conversion rate and 1-year conversion rate. And the main advantage of this model was that it is a fundamental model to create the payback optimization, automated one, that runs every day. And every day we automatically adjust our budget for advertising campaigns depending on the prediction of conversion rate and lifetime value. I will cover lifetime value a little bit later. And you could imagine that having automated system is really a powerful tool for the large marketplace and powerful tool for our marketing. And next, on the top of that, we also built a really interesting survival model that helps even more increase accuracy of conversion rate prediction by 5%. And this model is based on survival regression. Like for me as a data scientist, it is also interesting that you could not only look at the point estimation of 1-year conversion rate. You can really understand how your conversion rate and cost per acquisition changes in time as time after the first sign-up pass. If you're interested, you could use Lifelines package in Python to do that. And we also compare with performance of this model with actual states and sometimes adjust a little bit our predictions to consume the latest actual data. Another really interesting model we have is model that predicts when existing user will make the next purchase. So every day we calculate the likelihood of the purchase for every user depending on the latest actions we have in the system. If you visited the site, it will mean that your chances to make another purchase are growing. If you haven't visited a site for a few months, your score will decay, as you can see here. So day to day, the chances to make another purchase will decrease. And this model is used to create email content that is more relevant for the user. Maybe we need to send some promo to get you back to the site, or maybe you just need to help you a little bit to make a better decision. And another core model we have is a model that predicts lifetime value. It has a long story and a lot of iterative work. We started with having, again, just 1 year prediction made with regression model. There were a lot of disadvantages for this prediction. First of all, when you are working with machine learning model, you obviously need some observation period. And if you would like to predict something, oh, it is better. Something for 1 year, you would need 1 year observation period. Within 1 year, our business changes a lot. So within 1 year, I don't know, within 3 months, we could make so many decisions that data from 1 year will be not relevant anymore. So we made a decision to switch from using machine learning model to a statistical approach and to use classic Pareto NBD model. And what is great here, if you are using this model and you have at least thousands of users, accuracy will be really great. Like you can see, for all our population, difference in counts, and by counts I mean number of purchases, is small, and the same is for AOV, which is average order value. And to explain this model, I borrowed amazing slides from guys who presented this model first on the Pi data in Seattle last year. Sorry. Something goes wrong with the microphone. If you look at these users, you could easily guess who is going to make purchases when. If you look at the first line, you would see that user used to purchase from us a lot, but then she decided probably to give up, so the user is died for us. On the second line, you can see that user is making irregular purchases with some very stable time periods. On the third line, you are not sure, so same for other cases. And you could make a really nice guess what's going to happen next looking at this data. And it is also important to understand settings of your business. So you could have continuous or discrete purchases. You could have a case when you have a contract, so you always know when user can cancel a contract, and you could have non-contractual setting when user can make a purchase anytime. thredUP, as well as Amazon or any grocery shop, have these continuous purchases in non-contractual settings. Sorry? Yes. Thank you. It would be easier. So, thredUP have these continuous purchases and in non-contractual settings. And for this is very popular case with well-established mathematical approaches to solve this question of lifetime value prediction. And Lifetime value prediction is break down into 3 cases. Predict lifetime, how long user will stay with us. Predict purchase rate, how often he or she will buy from us, and predict average order value or monetary value. In classical Pareto NBD model, you use your data to estimate parameters of distributions for each component. Number of purchases, lifetime value, monetary value, and you combine all this stuff in the end to get estimation of your lifetime customer lifetime value prediction. I will not touch a lot monetary value prediction, just to say this model, there is a great lifetime package in Python that really fitted to predict average order value. I would like to talk a little bit about N prediction. N is number of purchases prediction. Classical Pareto NBD model is great, but it is a little bit too expensive to estimate parameters of this model. So in recent analysis, they show that better geometric model is better. It is really similar in performance, in terms of performance, but way easier to implement. Again, if you implement this model, you could, instead of having this 1 year end prediction, like one point in time, you could have like continuous estimation of the number of purchases as time since the first purchase passes, which is more handful and better for your analysis. If you imagine having these 2 models, like you could have moved from having a state where you make a lot of assumptions to calculate your lifetime value to the state when you have a monetary value estimation, which is called AOV here, and estimation of number of purchases, which is called count. And this is it. Yeah, you have 2 models, 2 accurate models, and you have your lifetime value. But after implementation, we mentioned some disadvantages. What are these disadvantages? If you look at the really new buyers on the left, you will see that in 1 week since the first purchase, model, which is blue line is showing number of purchases in time, is under-predicting the actual number of purchases. Which is bad, because this is like for a business point in time when you have to make a decision if you are spending more money for some campaign or for some channel or not. You would like to know that immediately when, or like in 1 week when after you created the channel. Later the model on average performs better, but what could you do with the first case? And as I mentioned, we have this statistical approach, and at the beginning we have machine learning approach, and we decided to combine them. Statistical approach here is great because it is using as simple parameters like classical RFM analysis. It is using number of purchases, user age, frequency of purchases. It is using all latest data, and it is producing user curve of these purchases in time. But ML approach cannot do this, but it is very specific to the user data, like wealth rank, recent search history, so you know more about the user. And what we made the model that predicts the actual 3 months number of purchases, and we are using our statistical model, and we are adjusting its prediction on the user level to make them more accurate for each given user. And what is amazing, if you look at the high level, if you look at the performance of Facebook as compared to SEO on Google, SEO you will see the same numbers. So you will have robust, consistent predictions. If you go deeper to smaller advertising campaigns, you would see the change because our individual predictions are getting more accurate. Another important model I would like to cover is TV attribution. When we first established TV, it was a big question to us, how do we know what users are coming to us after TV ads? So we know this time when the agency allocated our TV ads. We clearly see the spikes. We saw more visitors, more signups, but we would like to get sense what is the incremental value of this channel, just to know how much to spend on it. So what we did, we created a baseline that shows us what would happen if we do not have a TV ads. We calculated the difference between baseline and the spikes we have during the TV spots. And we assume that this number of users signed up because of TV. But they just Google us, so in terms of marketing, we will assume that these users are organic because they saw the TV, they Googled thredUP.com, and they came directly to our site. So we took all users who signed up within a few minutes after the TV spot, and we calculate this difference between baseline and number of users in baseline and spike. And we randomly pick up the users from the cohort of users who signed up after TV spot and assume they are TV. And this may sound a little bit naive, but it helps us to understand efficiency of a really great channel, TV, with a large budget and make better decisions. And we will iterate on this channel to make our attribution system better. And just to touch a little bit, another interesting project we had was multi-touch attribution. You could imagine that after signing up to the first conversion, user can potentially visit our site from different channels. Like she may came to us from the Facebook ad and sign up, leave our site for a week. After that, click on email and get back to the site. And it was interesting for us to understand if it is true that some users are click on different paid ads to understand if we are over or underestimating the power of some channels. And we made the model that weights each channel, that accounts for all history of interactions with our site. And this model showed us an important thing, that if user came to us from Facebook, she is very likely to use Facebook or directly come to our site. So interaction power is not that great, so we can rely on the current model when we are investing in the paid channels to attract users, and after that we are pushing on SEO, on emails, on improving our site to make user experience better and to motivate our best users to come back. And this, as a part of this project, we made this great schema showing how the user journey starting from the sign up to the conversion or stale state when it's not likely that she will make her first purchase. All numbers here are made up. They are not real, but our marketing team loved that absolutely. They were crazy about this stuff. So thank you very much for your time. And we are hiring. We have a lot of great tasks, as Chris mentioned at the beginning, so come to join us. And I'm ready for questions.
Chris, Tetiana, thank you. Questions, please.
Thank you for your talk. It was very interesting. I have a question. Does your system of these models, was it wrong that, or was it contradicting your intuition that it telling you that this channel will be prospective and using it not or different? And how do you beat problems like this?
Like, do you mean you expect the channel to be better, like to perform, the users to perform better than the average, but in fact they don't?
Well, yes, and I know that marketing, machine learning, and something like this is slightly different from marketing, just selling product or something else. So I'm asking about this one.
It is a really good question, Chris. Should I answer?
Sure.
Okay, so yes, it happens when you, and it could even happen for the channel when you expect the performance to be good, and in fact users are really far below average. And if we see this on the level of channel like Pinterest or other channels, you would make a decision to decrease your budget or even just stop spending on the channel, and we are super flexible, so we are making decisions very fast, we are super proactive in that. If we're talking about some campaign, which also happens, like for the largest channels we have this automated system, so the system will just not spend money for that. Talking about counterintuitive, yes, it happens. Well, humans will make decisions, but we know how to react on that.
I mean, the other thing I'd add is when we see those situations arise, it actually is a good indicator that there might be something fundamentally wrong that's been introduced in the product. And so it provides a good feedback loop that when you see the model, the users in a group didn't perform to the model, you ask why, dive a level deeper, and now you start to actually diagnose, is it the model? Or is it actually something we fundamentally broken, and can we find that? And there's been cases on both sides of that, right? Where you change the experience over time, and ultimately this has become an alert to you to say, look here, or look at these areas.
Thank you for your speech. One thing was interesting for me. When you told about when we get customer, when we get user, we need to understand if she will still be in our system. So does it mean that it will be only women that uses your service, or maybe not?
This is an amazing question. Yes, so far we are selling, we have only women and kids clothing on our site. We think about expanding this, and Chris, if you have something to add here.
We get asked the question a lot. One of the reasons that we chose to strategically focus on women is to make marketing more simple. When you have one or fewer demographics to target, you can get your messaging tighter, your advertising, your copy, your creative can all be very focused, and then you can test within those constraints. You open it up to more demographics, and now your permutations of work expand. Eventually, we may expand out to do men's clothing as well, but we do have male customers today, and they buy either women's clothing or kids' clothing. We just choose from our positioning and branding to focus on women, to focus on moms, and that life cycle of trying to upgrade your closet or upgrade your kids' closet as they grow.
Hi, I have a question about Facebook targeting. So, can you slide? It's the beginning. Yeah, here.
This one?
Yeah. So you divide your whole audience into 4 groups: high, medium, low, and discover. And then you just give this audience to your SMN probably, and they fill something formulas into Facebook Ads Manager, than targeting is doing. But do you think it's a good way to use machine learning here also? Because machine learning can understand how to divide this audience, for example, media, into also clusters users, for example, business ladies or just loving mommy. And then your recall will be increased, sure not for 15%, but for 4-6% it will be also profit. So if you use it, can you explain how did you use it? If not, so probably you will have work on it, research and so on.
Great question. We do experiment a lot with this segmentation, and one reason of working in the way I mentioned is that we have that we established an automated way to create these audiences, and as a step one, it was easier to rely on the one score, which is updated every 3 hours, so it's really dynamic one. And it was easy to, based on that score, make fully automated systems. That we were not passing like CSVs to manager that manually does it. We are uploading this to Facebook automatically. And now this system, great system made by our data engineering team, is ready to consume like different segmentations. And as we have this power, we are experimenting if we can make like a better splits, as you mentioned. For example, unsupervised segmentation. Or we also had the idea that okay, I will not go back to multi-touch attribution, but we also had the idea that complementary to these like intention score, we can also calculate a score based on channels that user used to interact with us. That was not that efficient, but we keep iterating. So with the question, with the way you mentioned as well. Thank you.
Thank you very much. You were talking about prediction of the next purchase, I guess. It seems if it's an internet shop, then the amount of users is much bigger than the amount of users which make purchases. So it seems that the data set should be highly balanced, and random forest in such a case tends to predict low values. How do you cope with such problems?
Thank you for the question. Just to sync with you, are we talking about this model? This is the next purchase, or were you asking about the first purchase? Just to make sure I'm answering the right question.
Maybe about, if I guess there was something about money that user will spend or not. So it seems that most of users spend zero.
Okay, I will answer the question as I understand it. Feel free to come with questions after that. If we are talking about imbalanced class, yes, this model with the next purchase is not imbalanced. A lot of users are making the next purchase in some limited time period. But for new users, yes, this is really a problem with imbalanced classes. And we use balancing for our random forests or for GBM models, which is there is quite straightforward way to balance classes for this problem and to make predictions robust. So, and feel free to join me after the speech if I didn't get your question, sorry.
So, who is winner?
The guy who asked about segmentation. This is super business trend.
Please applause for you, and this is a mouse.
This,
Please.
thank you.
There you go. Thanks.
Applause for Chris and Tetiana.